Problem 1 is x squared plus 2x plus y to the fourth plus y plus 4y equals 5. For part A we have to find the derivative, so 2x dx over dx, but that cancels to 1, so that's gone, plus 2 plus 4y to the third dy dx plus 4 dy dx equals 0. So we get 2x plus 2 plus 4y to the third dy dx plus 4 dy dx equals 0. And then we subtract this, 2x plus 2, in order to get dy dx by itself. It's 2x plus 2. That cancels, so we have 4y to the third dy dx plus 4 dy dx equals negative 2x plus 2. We can then factor out a dy dx, which gives us 4y to the third plus 4 equals negative 2x plus 2, and divide by 4y to the third plus 4. 4y to the third plus 4. That cancels, which gives us dy dx equals negative 2x plus 2 over 4y cubed plus 4. Oh, sorry. We can then simplify this, which gives us dy dx equals negative 2 over x plus 1 over 4 y cubed plus 1. This then simplifies to negative 1. We don't really need the 1 there. Negative x plus 1 over 2y to the third plus 1. And that is what we were trying to solve for A. Part B asks us to find the tangent line at negative 2, 1. So in order to do that, the equation to find the tangent line is y minus y1 equals x minus x1. We need to first find the slope, and in order to do that, we have to plug it back into this equation. So we do negative 2 plus 1 over 2 times 1 cubed plus 1, which then is negative 1 over 2 times 2, which is 1 over 4. That will be our slope. Since 1 over 4 is our slope, we have to plug it back into the equation y minus y1 equals x minus x1. So we do y minus 1 equals 1/4 x plus 2, since it was asking for the tangent line at negative 2, 1.
Okay, now we find this is the tangent line. For C, you have to, so it's asked for to find a, so for C it's asking for to find the two corner point on the curve where the line tangent to the curve is vertical, so it's k over 0. That's vertical line. vertical line. Since it's k over 0, so it's undefined. Now you plug that to k over 0 equals to the derivative of x dy over respect of dx, which was negative parenthesis x plus 1 over 2 parenthesis y cubed plus 1. To make the top value by itself, you have to multiply it by 2 cubed plus 1 to the both side. 2 cubed 3 plus 1. So this cancels out, so you're left with 2 parenthesis y cubed plus 1 k over 0 equals negative parenthesis x plus 1. You multiply both sides by 0. This cancel out, so you're left with 2 parenthesis y cubed plus 1 times by k equals, this one becomes 0. Now you do k, the original was k cubed plus 1 equals 0. Now you divide by k. Let's cancel out 2. You left with 2 parenthesis y cubed plus 1 over this one becomes 0. So you divide by 2 to both sides. This cancel out. You left with y cubed plus 1 equals 0. Now you subtract 1. So you're left with y cubed equals negative 1. Now you cube root negative 1 to make y itself. So y equals negative 1. So that's the y value that we find. Now you have to plug in the y into the original formula, which was equation, which was x cubed squared plus 2x plus 4y to the fourth plus 4y equals 5. Now you plug in negative y into y. So it's x squared plus 2x plus negative 1 to the fourth plus 4 negative 1 equals 5. Now you do x squared plus 2x. This one becomes plus 1. This one becomes negative 4 equals 5. Now so it's plus 2x. You combine the like term, which becomes negative minus 3 equals 5. So you're trying to make a quadratic formula, so you move 5 to left, so you add 5. So the whole equation will become x squared plus 2x minus 8 equals 0. Now you do the diamond, so it's going to be 8 at the top, 2 at the bottom. So you do 4 times 2, negative 2. Then will be x plus 4, x minus 2 equals 0. Now we set this one to a separate equation, so it's x plus 4 equals 0, x minus 2 equals 0. So now it becomes x negative 4 and x plus 4. X equals 2. So this is the x value that we find. So the coordinate point that we find was first one was negative 4 comma negative 1, and the second one was 2 and negative 1.
Okay, now we're going to do for D. So here we're going to find a possible curve from a horizontal tangent at a point where it intersects the x-axis. So to find the intersection in the x-axis, we know that y has to be 0. So to check out if it is possible, we do dy over dx equals negative x plus 1 over 2 y to the third plus 1. Then we plug in the derivative 0, and will be equal to negative x plus 1 over 2 y to the third plus 1. So 2 pi. Then we multiply by 2. So this cancels off and multiply the other side by 2, and it's 0. So it's 0 equals. So we distribute the negative to the parentheses. So it will be negative x minus 1. So next we add 1 to the other side too. So it will be 1 equals negative x. So we divide by negative 1 to get out the negative x. So it will be negative 1 equals x. Now we plug in negative 1 to the original equation. So it will be negative 1 over 2 plus 2 over negative 1 plus, so the y, we plug in the y2 will be 0, and it will be to the 4 plus 4 multiplied by 0 equals 5. So we want to find out it is equal to 5. So when we solve this, we got negative 1 equals to 5. And as you see, it's not equal to 5. So now, if it is not possible for tangent at points where it intersects the axis, because negative 1 cannot equal to 5. Thank you for listening, and we finished for the first question.